it's Mrs. Weethy here for video lesson number 15 on dimensional analysis. Now, dimensional analysis is also called the factored label method or unit analysis, depending on which school of thought that you're looking at. So what is it? It's a method that is used to convert from one unit to another using a conversion factor. So you have a lot of terms here. Conversion factor is another term that we're going to define. A conversion factor is a ratio between equivalent measurements derived from an equality statement. And yet another term, equality statement, which is a statement between the equality of two different units. And you know what equality statements are. You've had very simple ones in the past that you have used, just probably didn't know it was called an equality statement. For instance, if you have 1 dozen is equal to 12. Okay, or 12 inches is equal to 1 foot. Those are equality statements. And we use the metric system mostly in science to convert from one unit to another. So for instance, an equality statement using the metric system that we would use is 1,000 milliliters is equal to 1 liter. That is an equality statement. Now, we use those equality statements as a conversion factor. And for every equality statement, you have two possible conversion factors. Now, in the definition of conversion factor, we said it's a ratio. A ratio is set up in this instance as like a fraction. So each equality statement can be written as two possible conversion factors set up like a fraction. So we could have 1,000 milliliters over 1 liter, or we can have 1 liter over 1,000 milliliters. So two possible conversion factors from one equality statement. Now, the one thing, when you set up your conversion factors, you have to make sure that the number stays with the unit. It belongs to the unit. Because if you swap those numbers, then you're changing the equality between those two units. In fact, you're making them not equal to one another any longer. So how do you know which one of these equality statement or conversion factors to use? Well, you always set up your conversion factor in this format. You want your unknown unit, the unit that you are going to solve for, is always going to be on the top part of your conversion factor, and then the given unit will be on the bottom. So that's the format that you're going to use. Unknown over the given, always. It doesn't matter what we work with, that is the format that you will use. Okay, so let's take a look at this. This is a dimensional analysis chart, okay? It has the SI prefixes, which is something that you should learn. So like the SI prefix deci means 10 to the negative first or 1/10. Centi is 1/100th, whereas hecto, it means 100. So those metric prefixes, you should get to know what they stand for. Milli is 1/1000th, where kilo is 1,000. It means 1,000. But the one thing about this conversion factor, I call it a conversion factor chart, but the SI prefix chart is set up like equality statements. And this is what I mean. If we see, you always have a base unit. Okay, a base unit is a unit without a prefix. So this is set up as 1. So you would, in front of these prefixes, you would put 1 of your base unit, this is prefix unit. 1 of your prefix unit is equal to 1 times 10 to the nth power of your base unit. That is the format that you would use. one of your prefix units, so you're always going to put a 1 in front of your prefix unit, is equal to 1 times 10 to the nth power followed by your base unit. And this is what I mean. Let's say we want to use grams, and I want you to show the equality between a nanogram, okay, the prefix for nano is, or N is the symbol, and gram. Okay, so I come down here to the prefix nano, so I'm going to say 1 nanogram, and I'm reading straight across. 1 nanogram is equal to 1 times 10 to the minus 9th of a gram. So read straight across. Okay, 1, it always comes in front of your prefix unit. 1 times 10 to the nth power of the base unit. Let's try another one. Let's say that we want an equality statement between a liter, okay, and let's say a picoliter. Okay, and the symbol for pico is a P. So I'm going to come down here and I'm going to find pico, which is right here, and I'm going to write my equality statement. Now, notice I have liters written first. It doesn't matter. Your equality statement is always going to start with your prefix unit. So you have 1 picoliter is equal to 1 times 10 to the minus 12th liter. Again, always start, doesn't matter the order that you're given, always start your equality statement with your prefix unit and read straight across. 1 prefix unit is equal to 1 times 10 to the nth power of your base unit. Okay, so let's go on. That is, so you're going to use this chart, okay, all the time when you're doing metric conversions. All right, now one other thing that is key in dimensional analysis is to divide out common units, which is what we call unit analysis. And we've done that a little bit already in some of the things that we've done. So we're going to divide out the common units from the numerator and the denominator. So if we take a look at this equation that we have right here, we notice that a lump is both on the numerator and the denominator. Twi'leks we can cross out. And what else can we cross out? Well, we have zog squared, which is zogs times zogs. So we can cross that out because we have zog times zog on the bottom. And what does that leave us with? Well, dunks times dunks, which would give us dunks squared. That is a unit analysis. All right, try this one. All right, you can pause this video, pause it, do your unit analysis, and then come back to the video. Okay, so now that you come back, let's take a look at what you should have done. Can we cross out kilometers? I don't think so. How about inches? Yes, we can cross out the inches. We can cross out miles. We can cross out feet. We can cross out meter. And we can cross out centimeters. And that's going to leave us with kilometers on top, hours on the bottom, and so our unit that we have left is kilometers over hour. Okay, so that is a unit analysis, which is something that I'm going to want you to do every single time. Number has to be followed by a unit, and you have to show those units dividing out when you do these problems. So let's take a look at a dimensional analysis problem. And I want you from now on to set your problems up like this. List your given, your unknown. You want your equality statement in a unit conversion, a plan, and a solution. So in this problem, we want to convert 750 milliliters to liters. So our given will be 750.0, which is significant. And we want to convert that to our unknown, which is liters. Okay, now take a second, pause the video, and go to your prefix sheet, okay, your conversion chart, and write down the equality statement between milliliters and liters. Okay, now that you're back, the equality statement, 1 milliliter is equal to 1 times 10 to the negative third liters. Now your plan. When you set up a plan, you always want to start with your given unit. Plans only can use units. You want to start with your given unit, and you want to work towards your unknown unit. So our given unit in this case is milliliters. And in our quality statement, we see that you go from milliliters to liters, and those are the two units that we have involved in our problem. So this tells us we only have a one-step conversion, simply going from milliliters to liters. Okay, that is a plan. Now the solution is putting numbers to the units. So our given is 750.0 milliliters. We're going to multiply that by a conversion factor. So it's always the given, and let me write this down here. You want to start with your given, multiply by the conversion factor, and that is going to then give you your unknown. Now sometimes you're going to have more than one conversion factor. We'll see that in the next problem. So our conversion factor, remember, we want the unknown unit on the top, which is liters. So we go to our conversion or our equality statement, and we see in our equality statement we have 1 times 10 to the negative third liter over, and we want the given unit on the bottom, which is 1 milliliter. And where did I get the 1 milliliter from? From the equality statement. So we're going to take this equality statement and set it up as the conversion factor with the unknown unit liter on the top and the given unit on the bottom. Okay, and if you have to write it down, make sure you write it down. Conversion factor, you want unknown. Oops. You want the unknown over the given. Okay, now solve. Multiply 750 times the 1 times 10 to the minus third. You want to round your answer to the correct number of sig figs, which in this case is how many? Okay, good, that is 4. So that will give us 0.0, I think that's what it is, yeah, 0.075 and 00 liters. So you have to have those two zeros after the 5 so that you have 4 sig figs. The 0 in front of the 7 is a place holding 0 and is not significant. Okay, let's take a look at another example. In this example, we want to convert 50,000 millimeters to kilometers. Now take a look at this. We have two prefix units. When you have two prefix units, you are going to have two equality statements. And the reason for that is your equality statement always has a prefix. Remember, it's always set up as one of the prefix unit is equal to 1 times 10 to the nth power of your base unit. So your equality statement always has a prefix and a base unit, not two prefix units. So you're going to have two. So our given is 50,000 millimeters. Line on top of that second 0 tells us that second 0 is significant. Now when I have two prefix units, I know I'm going to have a plan. So I'm going to start with the plan for, well, we can actually put in the unknown, which is kilometers. Before I do my equality statements, I want to do my plan. So I'm going to start with millimeters. And my base unit in this case is meters. So I'm going to take millimeters and I'm going to convert that to meters. Remember, it's always either a prefix unit to a base unit or a base unit to a prefix unit, because that's what's in your equality statements. So that's the first part of my plan, millimeters to meters. The second part of my plan is now I'm going to take meters to kilometers. And again, I have a base unit and a prefix unit. And that's the second part of my plan. So I need two equality statements. My first one is between millimeters and meters, and my second one between meters and kilometers. So stop the video, look at, or go back and look at the prefix sheet, okay, and then go ahead and write your equality statements. And so if we go back, we'll see that 1 millimeter is equal to 1 times 10 to the negative third meter. And then we have 1 kilometer is equal to 1 times 10 to the third meter. Alright, so now we have our two equality statements, which we're going to use as conversion factors. In our solution, we start with the given quantity, which is 50,000 millimeters. And we're going to multiply by a conversion factor. It goes from millimeters to meters. Now the beauty of the plan is that arrow is always pointing to what unit is going to be in the top part of our conversion factor. And so the first part of this, we are solving for meter. So using this first equality statement, I want to put meter on top. And in the equality statement, we have 1 times 10 to the minus third meter over 1 millimeter. So those numbers have to go with their respective unit in order to be equal to one another. So now we're going to carry this through to the second part of our problem, where we're going from meters to kilometers. We have to use the second equality statement. Because we're going 2 kilometers, that's our unknown, arrow is pointing to kilometers, that is going to be on the top part of our conversion factor. And from the equality statement, we see that we have 1 kilometer over 1 times 10 to the third meter. Now, if you're working with the units like you were supposed to, you will see that millimeters divides out, meters divides out. That leaves us with kilometers, and that's what we're solving for. So how do you do this mathematically? Anything on the top you multiply by, anything on the bottom you divide by. So 50,000 times 1 times 10 to the minus third. Then we divide by 1 times 10 to the third. Round to the correct number of sig figs. In this case, our answer is 0.05, but we need to have 2 zeros after the 5 because we had a line on top of that second 0, which tells us that everything up to including that 0 is significant. Finish that off with a unit, kilometers, and that is the solution to our problem. Okay, that is dimensional analysis until video lesson 16 and the last one of the unit. This is Mrs. Wheathy. Goodbye for now.